the cube v, okay, all over the x raised to the power 3. Then plus, let's repeat what we have here, which is the squared v over the x squared multiplied by the u over the x, multiplied by the u over the x. Then opening this bracket, 2 times the first term will give you 2 du over the x, okay, the v squared over the x squared. Then plus 2 times the second term will give you 2 dv dx, okay, the squared u all over the x squared. Then plus, here is v the cube v over the x cube, then plus the squared u over the x squared dv dx. Okay, so we are going to collect the like terms at this point. This one does not have any pattern at all. So this one, let's look at what's happening here. Let's bring down the first term. Notice in the second term that I have the u dx somewhere, and also in the first term, these two terms are the same. Everything here are the same. So that means I will combine them. 2 plus 1 here will give you 3. So this is 3. Let me start with the u over the x. 3 du over the x. Then the squared v all over the x squared. Then plus, I'm done with these two parts. Then plus this term and this term are the same. This is the u over the x squared. Okay, so here I think when you combine the two of them, you have 3. Okay, this is 2 plus 1 will give you 3 du dv over the x. Okay, then the squared u all over the x squared. Then plus the last term, which is v, but this cannot be v. This number cannot be v. This is v, the squared. There's an error here. Let's make this correction. So this is u, not v. Okay, so I'm going to have v the cube u all over the x cube. All right, so this is the third derivative of the function, and something is happening here. Notice that the pattern is 1 3 3 1, which are the coefficients 1 1 1 2 1 1 3 3 1. Is there any way we can generate this number? Let's look at Pascal triangle. Here is 1 1. We always start with 1. 1 plus 1 is 2, then end with 1. You start with 1 again. 1 plus 2 is 3. 2 plus 1 is 3, then we end with 1. We start with 1 again. 1 plus 1 is 4. 3 plus 3 is 6. 3 plus 1, 4. Then we end with 1. And this thing continues like that, like that. So we have 1 and 1, 1, 2, 1 in the second term, second equation. Then third equation, we have 1, 3, 3, 1. That means the first equation should have 1, 4, 6, 4, 1. This is the pattern we have generated. So if I want to do the fourth equation without wasting much time doing what I did before, notice that you always have u. The first term u will remain. So here, instead of having 3, I will have 4, which is dv. I will differentiate the second one 4 times, which is the fourth derivative of the second one, plus, okay, let's not worry about the coefficient now. Then plus, we don't have to worry about the numbers in the front for now. Then I will differentiate the first one once, and differentiate the second one step down, which is 3 of the second term. You go down 3 steps. Now, notice that the multiplication of these two must give you the answer in the left side. So let's go again. I will take the second derivative of the first one, differentiate it second time over the x squared. Now, the second time we go down by 1 step again, which is the squared v over the x